Okay, I hope you can hear me. And you see the slides also on the screen, hopefully. Very good. Thank you so much. Thank you. So I think we can start just exactly on time. I think more people will join later, but not to really take your time more than needed. I'm very, very happy really to welcome you to this workshop, to this webinar actually. So my name is Angelos Amditis. I'm a research professor and director in the Institute of Communication and Computer Systems in ICCS. Together, we're going to discuss about social sciences and humanities in AI-driven CCAM. And especially we would like to focus and really discuss how we can move on from principles to actual practice. And we will see exactly why this is important for our area of work. This is actually a webinar for which we have been looking forward for some time now. And I hope that you will enjoy it as much as we do. Within the Hidden project, which is the initiator of this webinar, we made a deliberate commitment to bring social scientists and humanities perspectives into the heart also of our technical work. Today is the moment where we would like to open this conversation even beyond our consortium and invite some of the leading experts in this area to join us and to discuss the importance of this subject. Let's go to the next slide, please. So a few words about, first of all, ICCS. ICCS has quite a large commitment in the CCAM work and has a quite good position in the CCAM ecosystem. It's actually between the top 10 key players in the European Commission CCAM ecosystem. We have more than 20 projects in the past in the area, and I think it's more than 6 right now ongoing CCAM projects, some of them that we are coordinating also. And our key aspects of interest lies within automated driving functions validation, on cybersecurity aspects, but also on CCAM networking. I'm speaking about CITS here, I'm speaking about V2X and all the related technologies and applications. And I mentioned before about Hidden. Hidden is the initiator of this webinar. It's one of our quite important projects right now, one of the flagship projects that we are running here in ICCS together with our colleagues. It's all about, as we call it, hybrid intelligence for advanced collective perception and decision making, especially in complex urban environments. It's a Horizon Europe project with 14 partners from all around Europe and 2 affiliated entities, around 5 million of EU funding in order to achieve our objectives. We are working on 4 specific use cases that I'll mention a little bit later. The duration of the project is 36 months. It's already almost more or less now 1 year of work. It started on July 2025. And it's in the core of this project. We are discussing about collective awareness systems that enable vehicles to detect occluded objects and specifically, even more specially, vulnerable road users in real time, combining machine and human intelligence, that's why the hybrid, for safer but also more ethical and explainable automated mobility. These 4 innovations that I mentioned very briefly now are what, in our opinion, set Hidden apart from other automated driving projects that may be focusing more on technical aspects. Let's move on to the next slide, please. So Hidden has 4 main objectives, as you see them on the left side of this slide. And it's working on 4 specific use cases, or if you like, scenarios. In every one of these scenarios, we are talking about vulnerable human beings, vulnerable road users, specifically in unpredictable real-world situations. And this is exactly why how these systems behave matters as much as whether they technically work. And when I speak about behavior, I'm speaking about from the ethical point of view, from the social point of view, from the legal point of view. So SSH is not just an add-on in Hidden, it runs through the entire project. So I would say it's principles by design inside the project architecture. And it goes through from the ethical framework developed within the project to human-aligned decision-making, to user acceptance that we do at the end, but also during the whole project. And of course, we will hear more about these things, especially how that works in just a few minutes after my initial introduction. So let's move on to the next slide. And why social sciences and humanities matter so much also in the area of CCAM. Why this is so important? Technology may be advanced, but adoption, trust, and impact are principles profoundly human. We could build the most sophisticated, if you like, CCAM systems in the world, but if our citizens don't trust it, don't understand it, or even feel left out by it, it will fail. Not technically, but socially. So this type of principles, SSH principles, brings 6 things to the table that technical development cannot do alone by itself. First of all, the understanding of human behavior, the framework for ethical responsibility, the legal framework related to that, the inclusive design, the trust and acceptance issues, and all the research related to that. And also, last but not least, the ability to translate our findings into policy. And actually, it's not just us saying that, the European Commission fully agrees on that. If you see the numbers, 40% of all Horizon Europe Pillar 2 topics between, let's say, 21 and 23 were all SSH flagged projects, while SSH is now a requirement across all clusters of work in Horizon Europe. If you check a little bit the 25-27 strategic plan of the Commission, it now mandates full aspects related to SSH involved from the design phase and all the way to execution. We can safely say now that this is not just a trend, but it's a clear direction for projects and for initiatives today and in the future. And this webinar that we are doing today is one of the ways for us to contribute to this goal. Let's go a little bit on the agenda of today's webinar. This is briefly around 2 parts, I would say. So the first part, we will have with us 6 top SSH experts, each bringing a different lens to the question of how social, legal, behavior, and policy considerations translate into the development of CCAM systems. So I have the pleasure to have with us Andreas Reiner from the Ingolstadt University of Applied Sciences and a partner of Hidden that will actually set the scene with a look at how SSH is embedded in the actual work of Hidden. We'll also have the pleasure to have with us Ibrahim Ozdurk from the Institute of Transport Studies of University of Leeds that will bring the perspective, if you like, of psychology into our discussion. Then our own ICCS colleague, Penelope Alexiou, that will address the aspect of societal considerations in our discussion. Then, of course, Julia Renzi from ICOR, that will speak for issues also very important related to diversity and inclusivity. Louison Dubos from PAVE Europe will cover the policy aspects that I mentioned before. And last but not least, Maria Cristina Guetta from the, sorry if I pronounce it wrongly, this one, it's long, but it's the Jean Monnet Center of Excellence from Recep Lasti at Suor Ursula Benincasa University of Napoli. I'm sure that Maria Cristina will do a much better job than me to pronounce that correctly when time comes. But Maria Cristina will walk us through the legal framework around inclusion in CCAM. And then this will follow by a part 2 in our discussion today, that will have a fully interactive session moderated by a top expert in our field, the good friend, Carol Schwanger, ITS expert and president of the relevant consulting firm, whose experience in connected and automated mobility, allow me to say, Carol, is second to none. And this discussion with some key experts that we'll have in a kind of virtual panel today will be open with a live poll, and then move into our discussion, and then, of course, open the floor to all of your questions. So I really hope you're going to enjoy today's webinar, and I'm now going to pass the floor to my colleague, Elena Daskalaki, which is Hidden's day-to-day project manager, and also our moderator for part 1. I hope you all enjoy. Thank you very much for your attention.
Thank you very much, Dr. Amditis. Hello from me as well. I'm very happy to be here today. My name is Elena Daskalaki. As it was just said, I am the day-to-day project manager of Hidden. And that's just a very short thought sharing, seeing the Hidden project evolve and grow every day. I cannot agree more and stress on how important the integration of social sciences and humanities is in the quality and impact of CCAM applications, but also how challenging it is. So I'm very much looking forward to listening to the talks that we have today and exchanging and reflecting on this very important topic. So without taking more time, I would like to directly give the floor to our first speaker. It's Dr. Andreas Riener. He's going to talk to us about social, ethical, and behavioral integration in Hidden. THI is one of Hidden's partners, so he's going to introduce and represent what we do in Hidden. Thank you very much, Andreas. The floor is yours.
So, hello, everyone, and thank you very much for taking the time to participate in this webinar today. The previous speaker, Angelos, has already introduced the Hidden project and some basics of each SSH. I will take the chance over the next few minutes to introduce our approach to address SSH in the Hidden project and also illustrate this with some examples from our project team at THI. So this has been mentioned already. The underlying challenge is that technology alone is not enough when we develop future mobility systems. SSH helps us to understand how diverse users with different backgrounds, cultural, cognitive, behavioral differences perceive, trust, emotional experience, and interact with intelligent systems in real-world contexts. And in particular regarding the behavioral aspects, THI, my project team here in Ingolstadt, addresses this not only in the Hidden project. So it's not like we did do it for the first time in Hidden. No, we also have launched a larger project that is funded by the German Research Foundation where we're focusing on a systematic investigation of behavioral modeling and also the prediction aspect. Without SSH, there's several risks. Oh, sorry, this was too quick, too fast. We have several risks if we not consider or apply SSH. We might misunderstand system behavior as a user. We exclude certain user groups. We're creating technologies that may be functional but not human compatible, meaning that the user finally does not accept and use. And this we have seen in the history several times already, and we like to avoid this for the future. So that's why we see SSH as an integral part in the hidden project. And this is already visible in the project proposal. If you just have a look at this, just one page from the proposal, you see that SSH is within hidden integrated in different activities. It plays a central role in the main work packages 2 to 5, which is visible here. And we also see that we have several experts in the hidden projects that are capable in addressing this SSH aspect, and also many of the other project partners that are not addressing SSH per se in the project have some expertise in this area in their local project teams. So SSH is a really deeply rooted in hidden, and if you just see where it's integrated, it's integrated in the whole project lifecycle. From the problem definition here in the top, through the human-centered design, the implementation, the evaluation, and also the societal impact assessment. THI and other partners in the hidden projects are particularly interested in monitoring human states, monitoring behavior, deriving behavioral models, and using these models for short-term predictions in order to improve traffic safety and interaction quality and make technology usable and accepted by the later users. We follow a user-centered design approach. So this is like specified in the ISO norm 9241. And which is also very important for us in the project is that we evaluate our solutions that we develop within the projects in a close to real world scenarios in user studies using both objective but also subjective measures. So that's one of the first things that we did in the hidden project was to come up with the first version of the hidden ethical framework or ethical and legal framework, which is now like a almost 60-page long document. It's also like public. Everybody can just read and access it. And this establishes a structured approach for the rest of the project to develop the trustworthy autonomous mobility by integrating the ethical principles, the legal requirements, and human-centered design throughout this entire AI-human interaction lifecycle. This framework that we come up with operationalizes fairness, accountability, we address transparency, safety, and human oversight. Hidden applies value-sensitive design. So this is proposed as a method here, which is so value-sensitive design, for those that are not aware of it, it's a method that systematically integrates human and societal values into design, development, and deployment of technology, like one of the central user-centered design aspects. And we will see how it works or how we did it, for example, in a couple of minutes. The hidden ethical framework also addresses the concept or introduces the concept of trustworthy automated vehicles. And in hidden, it's based on 3 main aspects, which we see here on the right side. We have ethical behavior, we have compliance with legal regulations, and we also address this via robust system performance. It means that AI-based systems should operate safely, reliably, this for sure, but also communicate transparently and works responsibly under real-world condition, respecting human values and societal needs. And this is basically what hidden is trying to achieve. If you look into the hidden approach, like the hybrid intelligent framework, then we see here at the bottom, the processing tool chain from left to right, ranging from here, we have driver and VU observations. We create models based on the collective awareness of human and AI views in the systems. We continue with the decision-making approaches, and finally also the feedback to the involved persons, drivers, via use through explanations and interaction cues, for example. Above this framework, we have, or above this toolchain, we have the hidden ethical and legal framework, which guides the development by applying, for example, a value-sensitive design. And now I'm showing you what we did in value-sensitive design. There's not much time for showing this, but I'll give you a brief intro. Actually, in 2 studies we have run so far in the project. So use case 1 is addressed here. So Angelos already gave a brief overview. Use case 1 is to protect the darting out child hidden by parked vehicles in a school zone. And this is what we have replicated here in a study. We used a large parked vehicle, which is here. This vehicle partially occluded the street crossing scenario. Participants, in this case, we invited older children, 15 to 70 years old. They had to cross the street. And then there was an automated shuttle bus, which is now not, you might see it a little bit here. This is crossing the intended path of the pedestrians or of the participants. And then participants later, they completed the questionnaire and the recordings. We recorded the movement behavior, the trajectories, and used this to map it to the DBB framework, the theory of planned behavior framework. And after that, so this is the value-sensitive design. So they experienced the situation first, and then there were all the kids that participated in an explainability workshop. And in this workshop, we used the NEED cards, which is a qualitative tool introduced by Mark Hasensaal, and also the envisioning cards, which were introduced by Friedman, to systematically explore the needs of the users, their value system, expectations they have in a situation, and also future-oriented interaction concepts to finally come up with explainable and human-centered AI systems as a solution. This is just a brief, 2 brief videos showing 2 types of persons we had. We had a risk-averse behavioral type. So let me see if I can play the video here. Yeah. So risk-averse behavioral type, meaning participant P13 in this case, carefully approaches the curb, wait until the shuttle bus has come to a complete stop, and then cautiously crosses the street, which you can see here now. Another participant, for example, participant 14, he just walks to the curb, crosses the street at running pace without looking. We did not instruct participants on how they should cross the street. This was just how they approached it based on their own, whatever investigation of the scene, their value system, and so on. So we see there's a large variance in the behavior. A second study that we ran, where we also applied value-sensitive design, was with younger school kids, 30 participants, and they we investigated the crossing behavior in group situations, also in use case 1. And these findings are also used to extract behavior models and develop prediction algorithms. So this brings me already to an end for my short Ignite talk. The hidden SSH approach, centrally, is rooted in the project. And this reflecting that SSH is essential to ensure that future systems are not only technically advanced, but also safe, trustworthy, and accepted by the diverse user groups. In Hidden, we integrate SSH throughout the entire project lifecycle, and we validate this in realistic real-world scenarios. So with this, I'd like to finish already, and I think there's enough time to discuss later in the second part of this webinar.
Thank you so much, Andreas, for the very interesting talk. Yes, as Andreas said, we will have time in the end to discuss and reflect on the presentations and anything else we would like to share and ask. So I will pass the floor to our second speaker, Ibrahim Uzturk. I'm sorry if I don't pronounce it very well. He's going to discuss about the human side of automation, psychology and behavior in CCAM systems. Thank you, Ibrahim. The floor is yours.
Thank you so much, Elina. I hope you can see my screen. So, hello everyone. It's so wonderful to see so many people who are enthusiastic us talking about the role of social sciences and humanities in CCAM systems. So, as Elina kindly introduced, my name is Ibrahim Öztürk. I'm a senior research fellow at the Institute for Transport Studies, University of Leeds. As my title suggests, I will be talking about a little bit of a human side of CCAM systems, going from psychological and behavioral perspective, while most of the research I will be talking about focusing on CCAM systems in general. Its relevance to AI-driven systems will become apparent throughout the presentation. So I will share some insights from two main projects that I had the pleasure of being involved. The High Drive recently concluded, and certain project that both of them are funded by the European Commission. So when we talk about CCAM systems, we often talk about sensors, algorithms, connectivity, and AI. However, research shows that many of the challenges faced are about the automated systems are not just technical challenges, but also human-centered and societal challenges relating to issues such as trust and acceptance, as Andreas already mentioned. So today, therefore, I will focus on the human side, how human perceive, trust, use, and sometimes even misuse automated systems. And this is particularly relevant to AI-driven systems because when we talk about AI-driven systems, they use machine learning models that can perceive, predict, and make complex, sudden decisions in a complex traffic environment. However, even the most advanced AI version doesn't operate in isolation. So at the end of the day, their safety and effectiveness of the system relies on the human interaction and how human trust and use those systems. One of the main reasons probably we are here and we are talking about SSH involvement in those projects is that CCAM system doesn't just take human out of the loop. So we are not removing human from the process entirely, and we are not basically eliminating the human involvement. But as a user now, we have different rules. We are making judgments, we are supervising systems, we are interpreting their behavior, and when it is needed, we are intervening to the system. And this is fundamentally a problem of, not a problem of automation, but a problem of human machine or human AI interaction. So even though that is the case, we are still seeing some systems acting human as a passive backup rather than some active partner throughout the system. For example, as part of the certain project, we are focusing on safety, trust, acceptance, and comfort in relation to CCAM and HMI components. And decades of human factors research shows that when if people trust too much to the system, they may stop monitoring it, and that may develop over-trust issues. Conversely, if they do not trust enough, then they may not use the system, and their expected benefits will not realize. And sometimes the most confusion is that system on, what is it doing, is especially problematic when we are talking about automated driving systems and the driving assistance systems. That is why trust calibration is even more important with the AI, because since AI can perform extremely well in many situations, users may overestimate its capabilities And however, failures may still occur in some edge cases, and ultimately AI is introducing a new layer of uncertainty to human road users. For example, in this context, one of the recent studies we did as part of the HideRI project highlights that people may accept different systems conditionally, reluctantly, even sometimes may reject the system, may reject using the system, but still acknowledge that the system is useful, socially acceptable, and there are many reasons behind this variation. So there are demographic, psychosocial, social, and cultural factors that affects that variation. For example, the figure you are seeing on your left is the one of the recent papers that we published looking at the behavioral intention and acceptance of driver monitoring systems. Those different colors are different user profiles, and we found that there is no single type of user or single type of acceptance attitude. So, but we found that even within the acceptance framework, acceptance may still coexist with concerns about the system. So people may still accept the system, but also at the same time have different concerns about the driver monitoring systems. We identify 5 different users from really enthusiastic to resistance, and with those clusters, we see that great individual differences when it comes to their acceptance or use of the system. While we often aim to create a system that is acceptable to the users, that might be sometimes misleading. So our goal is to realize true benefits of the system, and while ensuring that we have the right level of trust, which sometimes we refer to as calibrated trust. In other words, people should trust the system as much as the system deserve to. So poor calibration may lead to dangerous over-reliance or complete rejection of the system. That means CCAM is actually operating in a very socio-technical system. So human interpret vehicle behavior socially. So was that merge a polite one, aggressive one, or the stopping behavior that Andreas showed, for example, was that a polite stopping behavior, or was the aggressive one? So and is that behavior of the automated vehicle predictable, or is that fair behavior? In that context, the cooperative systems are not just judged based on road traffic rules or regulations, so they are also judged against social rules or social norms around the area. So when we are talking about that, we are also referring to the traffic culture. In the context of AI, AI-driven systems must be able to understand and operate alongside with the humans in a very shared environment. So this requires technical accuracy as well as social compatibility. So, for instance, the way that automated vehicle systems merge or yields is interpreted based on both technical terms and also human social expectations. So in that sense, I think we can conclude that social sciences and humanities are not just add-on or a section that we are writing as part of part B section. When we are writing that part, they help us to design design the systems, design our projects, and understand how people understand, predict, and work with the CCAM systems. This includes interface design, behavioral modeling, training strategies, or regulations based on actual human behavior rather than simple assumptions. In order to translate the principles into practice, we must treat human as a design source rather than a problem to be eliminated. And in that way, CCAM can only succeed if they are built around human capabilities, limitations, and social behavior. So maybe my final word is the future of CCAM is collaborative as much as it is automated. So thank you so much.
Thank you very much. Thank you. Very, very interesting. So I think we can directly move on to the next presentation. And this is from Penelope Alexiou from ICCS. She's going to be discussing on integration of societal considerations into emerging technologies and traffic safety culture. Thank you, Penelope. The floor is yours.
Thank you, Elena. Can you all hear me? I guess yes.
Yes.
Thank you. Thank you. Hello, everyone. I am Penelope Alexiou. I'm a sociologist of transport and mobility at ICCS. Thank you for having me in this webinar. I think it's a great opportunity to create essential and meaningful synergies within the Hidden project. My presentation is titled Integration of Societal Considerations into Emerging Technologies and Traffic Safety Culture. And what I am about to do is to share insights from expert interviews conducted within the Roads for All project. It's actually the work I have done with my colleagues Lazaros Giannakos and Konstantinos Fokias. I am having an issue. I'm not sure if you can see my screen. Okay, I think okay.
We can see your screen.
Okay, thank you. Okay.
Now
So,
full screen.
Okay, perfect. So to begin with, one of the most important insights was that safety challenges are not purely technological, they are systemic. Emerging mobility technologies are transforming traffic environments, but also increasing complexity. CCAM, ADAS, automation, and micromobility are reshaping mobility systems, which means that we have mixed traffic environments that are becoming more and more complex. Cities remain largely car-centered, and new technologies create new interaction patterns, behavioral uncertainty, and new risks for vulnerable road users. Speaking of VRUs, vulnerable road users, they should not be treated as edge cases, but as a core, a starting point for system design. VRUs, for example, pedestrians, cyclists, women, migrants, older people, disabled people, children, etc., consistently emerge as the most affected group. An important societal angle here is that vulnerability is not only physical, but also social. As expert we have discussed with, said that stressed out issues related to digital literacy barriers, accessibility barriers, language barriers, and gendered safety perceptions. Another key insight is that risk is system dependent, not mode specific. The interviews identified three broad risk categories. The first one is the behavioral risks, where experts mentioned overtrust in automation, misuse of ADAS, distraction, and risky micromobility behavior. The second risk category is system-level risks, which includes fragmented governance, weak enforcement, infrastructure not ready, and unclear interaction rules. The last one is the cultural dimension, which is linked to safety culture matters, the fact that technology alone cannot change the behavior, and trust and understanding shape adoption. So technology alone cannot deliver safer mobility without behavior alignment, inclusive design, and governance coherence. Based on these insights, an important question is how societal perspectives can move from theory into practical implementation. For example, over-trust in automation highlights the need for better system communication and user training. VRU, vulnerability, points towards safety by design and prioritized VRU detection. Behavior shapes safety outcomes, so we have to move to human-centered AI and behavioral evaluation. Mixed traffic complexity requires infrastructure design and clearer interaction rules. Exclusion risks highlight the importance of inclusive and accessible mobility systems. And lastly, weak enforcement needs governance and monitoring mechanisms. So experts converge on four main recommendations. The first one is the systemic integration, where technology, infrastructure, governance, and behavior must evolve together. The second one is inclusive mobility design in order to avoid reproducing inequalities or reinforcing existing ones. The third one is education and enforcement, which both are necessary for lasting behavioral change. And the fourth, experts stress the importance of improving safety indicators beyond crash statistics, including behavioral metrics, near-miss data, and perception of safety indicators. So to conclude, the future of CCAM is not only a technological science, it is also a societal one. Human-centered mobility requires the integration of societal perspectives from design to deployment. So that is all from me. Thank you very much for your attention, and I'm looking forward to hearing the next speakers. Thank you.
Thank you very much, Penelope. As a note, you can already place your questions in the Q&A section if you wish. And with this, we will move to our next speaker. I would like to invite Giulia Renzi to speak to us about leaving no one behind, diversity and inclusion in CCAM. Thank you, Giulia.
Thank you, Elena. I think you can see my presentation. Good afternoon, everyone. I'm Giulia Renzi. I was the coordinator of the Symphonica project, where our main focus was to never leave anyone behind. That was our motto. I will go through some details. We have finished our project at the end of August 2025. And what we aim to do with Symphonica was to study social innovation to foster inclusive CCAM. So what drove all our project was to study what hopes, fears, needs, expectations do people have as they journey through the emerging world of CCAM and innovation applied to mobility in general. So what we did was to create a strong knowledge base, mapping user needs and requirements, especially for vulnerable users, but not just for them. We use the term of people with mobility challenge in order to build an inclusive CCAM transport system. Of course, that knowledge base is essential in order to enable stakeholders to take informed decisions for societal fairness, social inclusiveness, and so on. We also worked through a participatory framework in order to be sure that we involved all the citizens and relevant stakeholders in order, indeed, to don't leave anyone behind. And of course, we provided several guidelines and recommendations for citizens, policymakers, stakeholders, and so on. We follow several steps. At the basis of everything, there was the co-creation of activities, which we found was the key in order to be sure that all the different voices were heard, and in order to be sure that what will be built when the CCAM will actually be included in all the mobility system in Europe will be actually for everyone and not just a solution for someone. And of course, we've developed some tools that I will speak in a while in order to share this knowledge and these guidelines with all the interested people. As I said, our motto was to leave no one behind, and we did have it in mind, performing all the activities. We talked with more than 1,000 people through interviews, focus group, and workshop, and then we reached more than 5,000 people through survey. The particularity was that we actually were able to talk with all the different users group or potential users group that you can see on the screen. So we spoke with gender-related vulnerabilities, digital vulnerable people, people with physical and mental disabilities, people with low income, rural inhabitants, and so on and so on. So what we collected, all the things that we collected can be found now in the Knowledge Map Explorer, which is one of the tools that we developed within Sinfonica in order to share with all the people the different view from the people that we talked with. So you can access the Knowledge Map Explorer directly from the Sinfonica website. And basically, you can select the area of interest. The contents are distributed according to different criteria. You can choose to get some recommendation based on the profile that best represent you, or you can directly consult the data collected in Sinfonica. And of course, you can freely explore the different contexts. So we thought to firstly divide the content that could be useful for category selection within Sinfonica. For us, it was very important to have a concrete knowledge base for the different actors involved within the CCAM decisions, and also for all the actors, all the stakeholders that are usually involved also in other CCAM European projects. So you can see in the screen all the different categories that we have imagined. As I said, you can go also directly on the research results. We have performed interviews, focus group, workshop, and the survey, so you can go directly there to look for results. From our experience through the co-creation with our local authorities involved in Sinfonica, we noticed that different methodologies to collect results work better for a specific target group. So you will find specific target group in these different categories: interviews, focus group, workshop, and so on. And of course, there is all the part of the guidelines and recommendation, which we think are very important. We have the policy recommendations, so where we focus on rules and regulations, market-based instruments, and infrastructure development policy. We have the guidelines on CCAM-based public transport operation to support the effective deployment of CCAM-based services. We have guidelines on communication regarding CCAM-based public transport. We started Sinfonica in 2022. When we went to speak with people didn't know what we were talking about. So there was a very low awareness of what is a CCAM and what are the autonomous vehicles. So we thought it was important to share our experience, giving recommendation on how to speak with the different people. Once again, we have to be careful because when you talk about inclusivity, we need to consider also be inclusive in helping all the people understand what we are talking about. And then we provided some guidelines for CCAM demonstration projects. as we know that there are many, as I said, CCAM projects, not just European, but also different in different countries. We think that all the data that we collected should be taken in consideration in order to assure that also, for example, the pilots are organized and built, having a clear idea of what means to be accessible and inclusive. So this was just a fast and I hope pretty complete overview of the thing that we've touched through Symphonica. Very glad to be here and very glad to hear the future question. Thank you.
Excellent, thank you very much. Let's move to our next speaker. So I would like to invite Louison Duvos to speak to us about EU policy framework for connected and automated mobility. Please, Louison.
Hi everyone, just wait 1 second so I can see all of you. Okay, so hi everyone, thank you for inviting me. So I am Louison Dubos from behavioural, and as said now, I will present you a general overview of the EU policy framework for connected and automated mobility. So just to start, so before to go deeper into the regulatory framework, I think it is important to understand how the EU has approached automated mobility over time. And what you can see in this slide is not especially a roadmap, but it's rather a definition of policy priorities that have been developed in parallel across several strategic initiatives. So first, everything started with connectivity, and the EU initially focused on enabling communication between vehicles and infrastructure as it is set out in the CITS strategy. So at that stage, automation was present, but more as a possible application than the main focus. Then we have strategies like the Europe on the Move and the Road to Automated Mobility Communication. And there the EU increasingly emphasized deployment and global leadership, giving more visible attention to automated vehicle as a strategic sector. At the same time, other priorities have been central in shaping CCAM vision. So with the European Green Deal, automated mobility has been linked to broader objectives like sustainability, decarbonization, and transport efficiency. In parallel, the Sustainable and Smart Mobility Strategy has promoted a wider transformation of the transport system, where automated vehicles are part of a system that combines digitalization, sustainability, and integration between different transport modes. In this sense, automated mobility is only one element within a broader vision that aims at transforming how the transport system as a whole operates. But this has been evolving with the Automotive Action Plan. Automated mobility vehicles become more central into EU policy. We can say, I think, that this is linked to the technological improvement of automotive mobility in the past 2 and 3 years. So this is why now we have a more global strategy. So with this Automotive Action Plan, automotive mobility is framed not only as a transport issue, but as a strategic industrial priority. So the EU aims with this action plan to strengthen its automotive sector and also support the transition towards software-defined and automated vehicles. There is also in this action plan a strong emphasis on technological sovereignty, especially in areas like artificial intelligence, and this reflects a growing global competition and also the need for the EU to maintain control over key technologies. At the same time, the action plan has reinforced the objective of scaling up deployments, especially by promoting real-world testing and cross-border initiatives, with the aim to move beyond experimentation, as it was the case and still a bit the case now. A key element also of this plan is the regulatory dimension. So the action plan highlights the need for a harmonized European framework, which will ensure that automated vehicles can operate across member states under consistent conditions and also without regulatory fragmentation. So overall, with this action plan, automated mobility is positioned as a strategic, industrial, and also regulatory priority. Then now let's go a little bit more with the regulations that have been placed during the past years. So automated mobility within the EU is not regulated through a single dedicated regime. It is rather addressed within existing legal framework governing vehicles, technologies, and also liability. So within EU vehicle law, automated vehicles are not defined as a distinct category. Instead, they fall under the EU type approval framework, which is a framework that sets the condition for vehicles to be approved and placed on the market. Automation is incorporated into this framework through specific requirements relating to vehicle systems. So the regulation, for example, on general safety establishes type approval requirements for safety features and provides a legal basis for the adoption of implementing measures concerning automated driving systems. And this different requirement has been further specified in the regulation 2022-1426, which establishes procedures and technical requirements for the type approval of automated driving system, ADS. And this includes conditions related to system operation, but also safety. Very quickly, I think it's important to highlight it. The EU applies the UNES regulation within the type approval framework. So which sets technical requirements for automated driving functions, cybersecurity, and software updates. And also, I would like to talk not only about the vehicle, but beyond those vehicle regulation, automated mobility is also governed through horizontal legislation on digital technologies. So, for example, in the Artificial Intelligence Act, it established requirements for high-risk AI systems, which includes automated driving system. In the Data Act, regulates access to data generated by connected vehicle. And finally, in the Cyber Resilient Act, it is established that cybersecurity obligations for products with digital elements. So finally, automated vehicles are subject to the EU liability framework, which applies to defective products that incorporate software and digital technologies. Finally, I would like to talk a little bit more about the implementation of automated mobility in the European Union and what has been done up to now. So the implementation of automated mobility in the EU relies on instruments that link technological development with real-world testing. So a central role is played by the Horizon Europe program, I think like most of you already know. While the CCAM partnership coordinates cooperation between public authorities, industry, and also research organizations. So these instruments all together are closely connected to pilot and demonstration projects, which allows automated driving system to be tested in real-life conditions and also to assess their performance. I think an important point also is, I would like to mention, is a recent large-scale demonstration initiative, which marks a new step and which aims at testing automated mobility at a broader scale. So together, these instruments support a continuous process linking research, experimentation, and the initial introduction of automated mobility in real-world conditions. That's it. Thank you.
Excellent. Thank you very much, Lison. We finally reach our last speaker for the first part of this webinar. So I would like to welcome Maria Cristina Gaeta to speak to us about occlusions in CAV systems, constructing a legal framework. And with her, we close our speaker part.
Thank you very much for giving me the floor. Just a second, I would like to share the slide. Can you see my screen?
Yes. Yes.
Perfect. So today I would like to stress the attention on occlusion in CAV system, constructing a legal framework with particular attention to liability, perception, and the architecture of shared responsibility. This is the point of view of my researchers on this topic that I have the chance to carry out at the Research Center in European Private Law for Sustainable and Trustworthy Artificial Intelligence, to which I belong at Sor Orsola Benincasa, University of Naples. In particular, the presentation roadmap is based on 5 pillars. First of all, I would like to analyze the legal issues of occlusion in urban CAV environment, then the shift to duty of care from human driver to autonomous system. Then the attention will be focused on the collective awareness and the architecture of distributed liability. The regulatory landscape will be underlined. And finally, I will put on the table the first conclusion on the open legal question. Starting from the legal issues of occlusion in urban CAV environment, the starting point is the technical reality. Connected and automated vehicles relying on line on sheet, on sensor, LiDAR, cameras, radar that cannot perceive objects that are hidden beyond physical obstacles. So in dense urban environment, like for example, the Napolitan environment, I'm from Naples, a city in the south of Italy, a building corner, a parked truck or other obstacles cannot be detected from the ADAS or other CAV sensors. So this is the context in which, under a legal point of view, we can develop the concept of occlusion, which is not a sensor malfunctioning, but is a structural limitation of the single agent perception. According to this concept of occlusion, the vehicle operates with a fundamentally incomplete picture of the environment. And in this way, different legal issues can be arise. In particular, according to traditional liability framework, where the attention of the liability was posed on the human driver, who perceive, decide, and act. When perception becomes collective and also algorithmic and even equipped with artificial intelligence, the role of the human driver is gradually being supplemented by and replaced by the driving system. According to this idea, is evident the shift in duty of care from the human driver to the human system. This is a scheme of different level of automation, from levels 0 to levels 5, according to the CCAM standard for autonomous driving system. For each single level, we have tried to identify the possible tortfeasor, the applicable legislation, and the insurance policy. How can be seen, even for the traditional automation and partial automation, the driver can be considered liable. When we arrive to full automation, of course, the driver does not exist and the liability go on the producer of the vehicle and all the people involved in the driving network. This because today, when we talk about the vehicle connection, we refer to different kind of connection, vehicle to infrastructure communication, which are the most pertinent kind of connection according to our webinar. The vehicle to vehicle communication, which is also very relevant because is the base for the interaction between vehicle and the street. According to this kind of communication that go inside a network known as Internet of Things, there is a collective awareness and an architecture distributed liability that we have to take into consideration. Concretely, the legal significance is that we have a collective perception system, and this technical architecture creates a new paradigm. Liability can no longer be attributed solely to a single vehicle or a single driver, but the network becomes a co-actor in every safety critical decision. This means the need to provide specific regulation for semi-autonomous or autonomous vehicle in the CAV mobility. According to this idea, we carry out a study that was published by Springer to verify which legal system in the world already provided the regulation for self-driving cars and which legal system still needs to go in this direction. And in particular, we tried to design a map of the world and one of the United States in order to see this kind of idea. And then after having analyzed what kind of which legal system already provided a regulation, we tried to analyze this regulation in order to verify who can be held liable in case of malfunctioning, in case of hidden of this kind of technologies and not of malfunctioning. So the difference of the paradigm is based on the concept of the state of the art. Because the classical tort law standard is based on traditional negligence law that based on a reasonable person. Moving from the state of the art for CAV system, the applicable standard shift to the state of the art in perception technology. So the question becomes, did the others perform at the level that the best available technology at the time of the development would have achieved? So to answer this question, is important to analyze the applicable regulation, and in particular, Artificial Intelligence Act for AI system compliance, but this is also only an administrative regulation. The European Product Liability Directive, the revision version of 2024 on strict liability, is the very central point for this kind of analysis. But also Vienna Convention on road traffic is very important because it focused the attention on the driver, that permits autonomous driving only if a system can be overridden by the driver, and then of course national legislation that change according to the different legal system. There is a policy dilemma based on the idea of safety benefit and the residual occlusion of the risks to try to solve this question. We have to analyze the different we have tried to put on the table 4 pillars for create an adequate legal framework. The first pillar is the liability attribution, of course. The second pillar is the mandatory data logging The third pillar is the standardized benchmark. And finally, the fourth pillar is the compulsory insurance that is very important, in particular where it's not easy to understand who is the third fisher. Concluding on this overview, perception is now a legal duty. The core argument is the shift from individual to collective perception in CAV system, which is not merely a technical evolution. It is a legal reform. The traditional driver-centric liability model is structurally inadequate for a world in which seeing is a network, an algorithmic or a distributed act. So we have to put the attention on the duty of care that must be reconstructed. The machine knowledge must be legally defined. And finally, a regulatory harmonization is really urgent. I finish here my presentation and thank you for the attention. Here you can find the scientific paper that was published by the researcher of the Research Center in European Private Law for Sustainable and Trustworthy Artificial Intelligence at Sor Orsola Benincasa, University of Naples, on the topics of the webinar. Thank you.
Thank you very much, Maria Cristina, and thank you very much to all the speakers. We heard indeed very interesting talks. Given that we are a bit in the second hour of the webinar, we propose to directly move on to the next part. To part 2, which will be an interactive session, and it will be moderated by Carla Schweiger. So I directly pass the floor to her to begin the second part of this webinar. Thanks again to all the speakers.
Thank you so much, Elena. I learned a lot over the last hour. In a few minutes. Thank you to all the fantastic speakers for your different perspectives. And I took away quite a bit from the discussion, but I think I'll hold my comments until we get into the bigger discussion with the audience. And at this point, I believe we have some Mentimeter questions that we're going to pose to the audience. And as you can see on the screen, there is a QR code that you can scan to get into the Mentimeter questions, as well as the website, the www.menti.com, and then the code that goes along with this particular webinar. So we'll give people a moment to scan or get into the website for the questions. All right, let's move into the first question. So, in your view, how well are SSH principles integrated into CCAM technical development? And the scale goes from not at all integrated to integrated very well. So we'll give folks a chance to respond to that. And I believe we've got the opportunity to look at the answers to these once we give folks enough time to respond. All right, how are we doing with the responses? We're settling right in the middle. So some people feel that it hasn't been integrated well, and others feel that it has been integrated well. All right, so the next question is, where do you think the biggest gap lies between SSH principles and practice? And here we have different categories for you to use in your response. And I think we had some really good, a really good knowledge base from our speakers on where these gaps exist. Give folks another minute or so to respond. I would agree, we've got the most number on the behavioral factors. And if I were answering the question, that's probably the category that I would choose as well. All right, so it's overall the behavioral factors followed by policy and governance as well as legal considerations. So let's move on to the next question, if we can. Who should be responsible for ensuring SSH integration into CCAM systems? So the choices are the engineers who are building the systems, the SSH researchers who are advising the engineers on building these systems, the policymakers who are regulating the systems, the users who are affected by the systems, the funding bodies, whether it's the European Commission or other agencies, public agencies, or the project coordinators. So we've almost got everybody responding. I'll give it another couple of seconds before we look at the results. So what are the results telling us? 38. The policymakers. That's very interesting, considering the information on the various presentations. So 40% the policymakers, and the next largest are the SSH researchers advising them. Very interesting results that I'm sure will carry into our discussion. All right, next question. Has your organization or project ever changed a technical decision based on SSH input? And once we get a few more responses, I definitely have some thoughts about this as well. All right, so what are the results telling us? That's very positive. I don't think I was expecting that, but that's a very positive response. I'm not surprised about the not sure, just because everybody's coming from a different type of organization within these types of projects. And on to our last question before we start our discussion. What would make SSH integration more effective in CCAM projects? So I believe this is an open-ended question. So it'll probably take a bit longer. User-centered design, absolutely. Accountability is a very important one, and in some cases hasn't quite been defined yet. Yeah, interfaces in the field. Yeah, having more SSH people involved in the project, more experts. And it's interesting that collaboration is kind of one of the bigger items that people cited. And I think that goes along very well with what most of our speakers mentioned today, which is the importance of co-creation, especially when you're designing the technology. Transparency also very important, which speaks to understanding exactly how a system was designed and what factors were taken into account. So those are still the two responses that are being given the most here. All right, shall we move on? I think the results of the Mentimeter, I think, reflected a lot of what we heard in the various presentations. There were a couple of things that I wanted to mention before we get deep into the conversation, and that is for those of us who have been in the transportation technology space for quite a while, we have lived through the era, unfortunately, of systems being designed without any input really from the users. And when I think back to what are some of those examples, like mobility as a service, for example, this was touted as being one of the best solutions to improving mobility for everyone. But at the beginning of the development, no one considered the people who would actually be using that tool to improve their mobility. So there was really nobody was looking at travel behavior, at how people are making mobility decisions, how they might utilize such a technology. Another example that really resonated with me as the speakers were providing their perspectives was early analysis of the use of automated vehicles. At least here in the US, there was a lot of discussion about how automated vehicles would improve mobility, particularly for vulnerable road users, persons with disabilities, older people, people of low income. But no one had incorporated those communities into the design of the early automated vehicles. It was in fact an afterthought. So I think we're now, as the title of the webinar suggests, moving this all into real practice is the most important part of everything. So I think if it's okay with everybody, I did have questions for our panelists that I thought might shed a little more light on moving these ideas into practice. And if I can start with Ibrahim, one thing that you mentioned that I've heard for a couple of years is incorporating cultural differences into the design of almost any kind of automation. This was something that really wasn't discussed early on in the sort of early design of automated vehicles in particular. So my question is, how can the differences in cultural and social norms across countries influence the acceptance and safe use of CCAM systems?
Thank you so much, Carol. It's a difficult question, and I'm not sure if I can provide one robust answer, but one thing that maybe will is kind of links with all of the presentations we heard today is, if we are looking from a very technical perspective, we are looking from developing one robust system. But that doesn't mean that that system will be operating across different countries, across different regions. And we see that even the practices within the same country might be quite different. So I am not talking about changing the system completely and designing something new for each country, each region, or for each individual, but we need to consider those practices and what people, even in a simple terms, what people are looking for from a vehicle might be quite different across countries and between individuals. So we need to look at those differences, and we need to do something to address those differences. That could be in a form of providing information about the systems differently, or advertising those vehicles, those technologies differently. So even those small changes would make a huge impact when we are talking about acceptance and actual usage of those systems.
Thank you very much for that answer. That makes perfect sense. I have a question for Penelope, and this is the key question of moving from research and consultation into embedding the SSH perspectives in the actual design of these systems, as well as the evaluation and the deployment processes that are being used. So if you can address that, Penelope, that would be great.
Yes, sure. Thank you, Carol. Well, I think that one of the most important things is to stop treating societal perspectives and considerations as something that comes only at the very end of the process, just to evaluate or validate the data, the technologies, after the main technical decisions that have already been made. Societal considerations and perspectives should be integrated from the beginning throughout the whole life cycle of each project and of all these systems, from design and development to testing, deployment, and evaluation. Through the interviews we conducted with my colleagues in Roads for All project, it became very clear that many safety challenges are not purely technological. They are behavioral, they're cultural, organizational, and systemic. For example, experts repeatedly mentioned issues such as overtrust in automation, different perceptions of safety among users, and especially among men and women, difficulties in interactions between automated vehicles and vulnerable road users, and inequalities related to accessibility and digital literacy. So there are things that technology alone cannot fully solve. This is where the societal perspectives become essential and important, and they can help us to better understand how people actually experience, interpret, trust, and use this system in everyday life, their everyday life. Their lived experience should be in the core of the designing new technologies. I also think that meaningful integration requires also interdisciplinary approach and collaboration. Social experts should be collaborating with engineers, policymakers, urban planners, and behavioral researchers. They should all work together from the early stages of each project. And another important point for me is also the evaluation framework, where it should not only focus on technical requirements and technical performance indicators, but also we need indicators that are related to trust, perceived safety, indicators related to user acceptance and user experience, so that we can actually provide inclusive frameworks and accessible frameworks. So overall, yes, I believe that societal considerations are structurally embedded when societal perspectives are treated as part of the system design itself, and not as an external or secondary layer that can be added afterwards.
I wholeheartedly agree with you. And I think here in the US, we have not necessarily started our projects, these types of projects, embedding everyone who is going to be using these systems from the very beginning, as you said, not as One of the speakers mentioned we can't consider, for example, vulnerable road users as an edge case. They're an integral user community that we need to consider at the very beginning. And this was also subject of a session at the ITS European Congress, where something else you just mentioned is critical, and it's having a framework for all of the various consulting entities, whether it's SSH consultants, the engineers, the public agencies, the regulatory bodies. It's having a framework for all of those groups to work together from the beginning, because a lot of those entities may never have worked together before. So thank you very much for that. I've got a question for Julia in your presentation. So this gets into how do we ensure that the CCAM solutions are designed not only for the average person. This actually goes way back to when we used to test the safety of automobiles. It was always based on the average person, not the person, for example, who is as short as I am or someone who's very, very tall, but the average person. How do we ensure that these solutions are being built for everyone, including the most vulnerable user groups?
Carol, I think that we have lost Julia.
Did we lose Julia? Okay.
Yes. So maybe we can keep the question for the end.
Sure. It's definitely an important one. So let me move on. All right, it was very interesting. This is a question for Louison. It was very interesting to look at how CCAM is really the regulations and policies have sort of evolved over time. And what would you say about what are the considerations for the continued evolution of CCAM, especially as we're considering the most vulnerable users? What does that look like in the future?
Thank you for your question. And I think it's a very interesting question because when I was still at the Commission, I made a research on the requirements for automated vehicles for people with disability and older adults. And I think from what I learned from the conversation with the associations and the experts is that first, we have to, I think this is also what you say, Carol, a bit earlier when you introduced a bit the session question, is that we have to stop considering that everyone will be capable to use automated vehicles. It's not just about the technology. It's about the whole environment in which people are living. Some people might need assistance to enter in the vehicle. Maybe they will need assistance from their home to arrive to the vehicle. And maybe some people will just need to be accompanied the whole time, as it can happen sometimes. So this is one of the considerations that should be taken into account, that some services that should be still continuing and should not disappear with the technology. One of the other points that I would like to raise is that it's about more digital literacy, but also how we learn about technology. And many people may not have the cognitive resources to learn new technologies or for totally changing the way that they collaborate or coexist with the transport system. So most of the time, what we know about the transport system is something that we learn from very young age. And I can say, like, okay, it's maybe about the smartphone, but it's not just about the smartphone. Tomorrow, when you will not use the vehicle, you will interact with the technology, and you need to understand when you have to cross. But the question is, if we totally change how we interact with the vehicle, will everyone be capable to coexist with the technology? And I think this is part of the point that should be also taken into account. It's something that I see very little considered. We are always trying to understand, well, maybe we should the blue light to say people, we need a smile, we need this, we need that. But maybe we should consider that for some people, it will not be possible to learn that. So maybe we have to change our perspective. And so I think like policy comes when it defines also what is the safest, but should ask for the definition of an index of what does it mean to interact, but really taking into account maybe the people that are the most marginalized first, instead of taking into account the wide audience, because 80% of the population will not have issue with using those vehicles. It's all the people that are already marginalized that may have more issues, and we have to take that in consideration, and they should be the starting point for designing the whole ecosystem. So I could talk for a long time, so I stop here.
I completely agree with you. If we design things for the most marginalized populations, it's going to work for everyone else. So it makes sense that that is the starting point rather than an afterthought. So I appreciate your answer to the question. Let's see. Do we have... Sorry, I'm just looking at whether we have...
I think we received a question for Andreas.
Okay. I'm flipping back and forth here.
In the document, Carl, I think.
Yes. Let me... For some reason, I don't see that.
Maybe, Sevi, do you have it?
I'll have it. I'll write it in the Q&A.
Yeah,
in the
great.
meantime, I also have a question from Elena. She's asking, what are the expectations of the SSH experts from the engineers and AI designers or developers? And how would they envision to interface, to optimize their input to CCAM designs? And this is also one of my questions, because in the Mentimeter, we mentioned collaboration a lot. We also had some answers that SSH actually impacted decisions. We had 12 people saying that. So it's really interesting, I think, Carol, to see what are the expectations and how this can be translated into practice, as we say.
And I'll leave that open to all of the speakers to provide your perspective on that. Expectations are extremely important here because it goes toward acceptance of the technology, but also, as we're discussing, how to put some of these things in practice. One thing that I mentioned earlier was this expectations of how all of the various groups working on these projects actually work together if they never have, and what does a framework like that look like? I think that's one key thing. I see the question for Andreas here.
Should I wait for this question, or may I answer to this actual discussion point? Because this is something
Please.
that I really like that is raised, because what we see in industry, for example, is the strong engineer-driven approach, where the users are not integrated, and also UX experts are only they are very underrepresented and have not that big role that they should have. We are really lucky in our university, because we have many aspects that now really helps us to consider the whole picture. So we are a university, like a mobility university, founded by the request of car manufacturer in Germany, like Audi and BMW, and also Airbus, which has also its headquarters just nearby. And based on that, so this was like these two mobility initiatives founded our university. So we have a very strong mobility focusing across all the the programs on the one side. Second side is that I personally, I'm heading the user experience design graduate program, which is an international program. So we have a lot of students from different parts of the world. So one focus area is Latin America. Another one is the eastern part, like Bangladesh, Pakistan, India, China. And this now brings us in a situation that on the one side we train people working interdisciplinary and interculturally together with within strong mobility focused projects, which are part of our programs. And also like applying the real user-centered methods and user experience design approaches. So we have all these, basically we train them, and we align this also with industrial projects or with needs from industry. So we are really, we are living all these, the questions that were just raised in our programs, and also we also translate this to our research projects, which is really a very nice thing. So what we have considered, for example, so there's so many aspects I could talk for hours. One aspect that I want to raise, or just to bring in here, because this was also like it was not discussed today, but what we see is that like the engineers that develop the products, they are typically males. So we also have a male biased engineering. Which means that it's all also optimized based on the request by the male users and based on the mental model that male persons have in interacting with systems. But more than 50% of the population worldwide is female. So why is it still the male-driven technical perspective that is like put forward when there is half of the population on the world are females? And this is really a problem that one of my PhD students, she graduated already last year. She looked into her PhD thesis and exactly this males-focused bias, and then how to address these and how to also fulfill the needs of the female users, and how to bring more female engineers to get on the table to discuss. So this is a really nice example. What is beyond the pure SSH and the cultural differences and the minority groups, there's so much to do. And I see it as in a university, as a researcher in a university, I see this as our contribution to the society to research these parts, like to research with minorities, to research with cognitive and physical disabled people, and like complement the typical company or industrial research, which is mainly focusing on the on the bigger groups, so to say, and not really addressing minorities.
I really like that perspective, especially bringing in the gender perspective. which we are discussing in a number of different areas within intelligent transport systems. But what I always find most interesting, when you study systems engineering, the systems engineering process, the first part of the process is needs assessment. So how has everyone skipped over, quote, user needs? There are multiple user groups. And if we're really taking systems engineering to heart, we would have considered all of this at the beginning, but that's not what we've done. So I very much appreciate your perspective on that. Johanna, you have your hand up.
Thank you, Carol. I'm Joanna Zanidaki, Executive Director of EU Policy and Innovation Research for SAE Group Europe, and we are co-organizing this workshop. And after Andreas mentioning the gender perspective, I couldn't stay silent because, you know, Carol, that triggers me. I wanted to... I know. I wanted to make a small point, which was very interesting for me. I am working on ITS for 15 years, so I am supposed to know that. But it was only last week in Budapest that I found out that there's a difference between safety and security. And safety is all about the accidents and the safety in the vehicle and the passengers and so on and so forth. And the security is intentional harm. And we, working in projects, especially in CCAM, and I'm not an engineer, but engineers, I'm a lawyer, but that's another story. But engineers focus on cybersecurity, mostly when they're talking about security and hacking and all that. And we don't really, within the project, think that part of the security in the security aspect is the harassment of female passengers, right?
Yes.
And what Louison was mentioning about some groups of passengers, categories of passengers, such as women or the elderly, they need help. So this is a discussion that it has come now for the past 2-3 years, while we have been focusing on automation that is going to be bringing all these disadvantaged, marginalized groups into mobility. And this is only after what, 10 years of discussing about it. This is where we started the discussion 2-3 years ago. And this is how SSH is bringing in these topics. And I'm, again, coming from the standardization organization, and standards are usually technical. And we're talking about interfaces, and we are talking about safety, and testing methods, validation protocols, and so on and so forth. And we are participating in this project and in other projects in order to understand how best to incorporate also the SSH aspects in the standards that have been until now so technical. And vulnerable road users, of course, have been the focus of our standards in SAE, but also other aspects, not the physical, as Penelope was saying, not the physical disability only, but also the social and the gender and more.
Yes.
So I don't want to monopolize it, and I know other people raise their hand. Thank you.
Thank you very much for that perspective. I completely agree. And we typically are not looking at those things where, especially in standards, because of the way technical standards, that evolution, we need to incorporate that as standards evolve, and some of the standards processes need to change to make sure that we incorporate those. Okay, moving on here. Ibrahim, you've got your hand up.
Thank you, Carol. And that actually nicely links with your last few sentences, because going back to Elena's question about engineers and AI designers and integration with SSH is, I think we need to change the way we work in a very simple terms, because until now, or in a general sense, the way the development of is more reactive. So something goes wrong, and then we go back to the social sciences and then ask, oh, what is wrong with this? Why this is not working? We develop very nice products. So I think then we need to be more proactive in many sense. And if we can do it, and that's maybe something that Joanna or Louison may answer, can we actually regulate that? Or when we are looking at the regulations, can we also look if the way it is done, is it also including that process?
Yeah, very good point. At the ICCS European Congress, we had some discussions about this. My personal feeling about it is we should not be funding projects that do not incorporate these things from the beginning. But that's just my opinion, and I don't know if anybody is listening. Louison, you have your hand up as well.
Yes, it was just to react to the conversation and to the points that have been raised. And I think it's important to highlight that in the history of transportation, this is the first time that it is not, it's not just about putting a new technology on the market, because what implies automated vehicles is not just changing a vehicle, like replacing a vehicle. It will change the whole transport ecosystem. And this is the first time in the history of transport that is happening. And this is the first time in the history of transport that we are really considering how to implement a new transport technology in the transport system. And I would say that we are starting from nowhere. We are starting from science, if I may say, transport science that was led by engineers to a new transport science where we are trying to including not only engineers, but different other fields, expertise. And I have to say that I think most of people, they don't know how to do, they don't know how to insert themselves. And sometimes when we talk a lot about acceptance and user acceptance, but I do believe that acceptance will have to work at all stages, and also accepting that we are limited in our knowledge according to the field we have expertise, and to be open to rethink everything. So this is just what I wanted to say. I will stop here, but I think it's an important point to mention.
I do too. I think it's an extremely important point to mention. And to go one step further from what you mentioned, most of our transport planning is based on modes. So we're building a highway, we're building a transit system. Shouldn't it start with there are people who need to go from point A to point B? What are their needs? I think we need to start there rather than starting with the mode. And you're right, automated vehicles are completely changing our ecosystem. So we do have to think about things a bit differently, for sure. I think we're at time. I know I didn't get to ask Maria a question, but can we go over a little bit, Sivi, or should we end it here?
I think 5 more minutes if everyone wants to stay, and also to hear from Maria.
Yeah,
I think that would be good.
Yeah, I would really like to hear from Maria. So in your discussion, you very clearly explained how the liability is changing based on the technology and a number of other things. One question, can a vehicle be held liable for what it should have done as it was driving throughout the network, even if it didn't receive information that would have informed it. I mean, this is a very, very complicated landscape when we're talking about automated vehicles, but I'm interested in your perspective about that.
Carol, thank you for your question. Actually, I think this is one of the most fascinating questions that as legal we can try to solve, and that start from the intersection between law, between software engineering, and also between considering the operation of the autonomous system. I think that the answer is no. A vehicle, or more appropriately, the manufacturer or the operator of the vehicle, cannot generally be held liable for knowing information it literally could not know or could not received due to an external failure of the network, the driving network.
Yeah.
However, of course, they can absolutely be held liable for how they should have known according to the a medium level of accuracy of the party involved. Actually, today, according to the current law, a vehicle itself is not a legal person. So even though literature is trying to provide the idea that vehicle can be itself liable, who can be held liable today, according to the law in force, are the driver, the manufacturer, the software developer, and the other operator. But of course, they can be held liable for what they should know, not also for what they should haven't known for a failure of the network. This is my idea on the topic, according to the researches that I have carried out on this in this domain.
Thank you so much for that perspective, because it is a very, very complicated issue. Absolutely. I think we've come to the end of this fascinating discussion. I wish we had another several hours to continue. I certainly had a number of thoughts from each of your presentations as well as the discussion, but I think we have unfortunately come to the end. And just, is there anything that Elena, you would like to add before we close up?
I think you moderated this discussion excellent. So I don't really have much more to say. It was really interesting from my side as well, being also from the side of the engineers. It's very important to talk and to listen to the perspectives. What I really enjoy is that there are so many different aspects, and sometimes we overlook at or how many axes exist, or we only focus on one or two of them. So yes, I'm very much looking forward to further exchange, and also as an engineer, I feel very curious to find good ways to integrate all these things in the designs and the developments of the systems. Very, very big pleasure to have met you all and heard your talks. And I think very important input for Hidden.
Absolutely.
Thank you very much.
I'm thinking that maybe we need a part 2. I don't know how anybody else feels about that, but excellent.
I agree. Yeah.
Okay.
Or we can put all the thoughts in an article.
That
It-
would be a great
yeah.
idea.
Yeah.
I've jotted an entire page of notes here that I would love to share with people. But yeah, that would be an article would be great.
Okay. Let's discuss about it. Yeah.
That sounds great. And I just want to thank all the speakers again. Thank the audience, folks that helped with the discussion. The recording is going to be shared afterwards. And I think with that, I will close the webinar. Thanks, everybody.
Thank you.
Thank you. Thank you very much.
Thank
Thank you, everyone.
Thank you,
Thank you,
everyone.
everyone.
Thanks, everybody.
Thank you. Bye.
Bye.